Hey, welcome guys. It's the Forensic Junkie here again, and today I'm going to be showing you all how to create or how to forensically acquire an image from a storage device, your hard disk drives, your SSDs, or your thumb drives. Today I'm going to be forensically acquiring the image of my 2 GB flash drive. It's already plugged to this virtual machine, and yeah, let's get into it. So I remember I made a video of forensically acquiring image but using a tool called DD, a command line tool called DD. Now, today I'm going to be using a similar tool called dc3dd. Now, I'm not really repeating myself, but I thought it pragmatic to create this video because in a forensic setting, DD is not really used. So maybe if you're doing real forensic work, most likely you're going to be using the tool dc3dd, and there are reasons for that. dc3dd is a more enhanced version of dd that was created or developed by the US Department of Defense Cybercrime Center, which means it has more accuracy, it's more reliable, and of course more powerful. Unlike dd, dc3dd has robust error handling, it has human readable progress display. It also has detailed logging and automated hashing features like you're going to see in this video. I'm going to be using the hashing feature. I remember in the last video, Didi didn't have that. So we can also do something that is really, really nice. We can split images into chunks. So let's say you're analyzing a very big hard disk drive or solid state drive, maybe 300 gig or something around that size. You can choose to break the images into chunks. So let's get in. First of all, yeah, we're going to be running as root user, and the next thing is to check the devices that are connected because we don't want to make the mistake of tampering with the wrong device. So we're going to see the devices that are connected to my machine using the command fdisk, sorry, fdisk. Yeah, so this is my main partition. This is the one I'm looking for. So this is my 2 GB flash drive, and it's located in that slash dev slash. So the next thing to do is to install the tool. Now I already have the tool installed, but if you want to install it, if you don't have it, you're going to type in the command sudo apt update. Now once you update your application packages, you're going to type in the command, but you don't need to type in sudo because you're already a root user. This is just a thing of it's unconscious. So sudo apt dc3dd, then you click enter and it's going to install dc3dd for you. Now the next thing you're going to make sure you do is to right block your flash drive. And I've made mention of this before. I said the foundation of forensic science is integrity. And you cannot maintain integrity if you are having data that is data that lacks data that is unanimous. So you're having one data here and on another place is showing something else. You don't want that. And we don't want anything to tamper with our image. We don't want anything to tamper with the data that we are acquiring. So we have to make sure that the flash drive or whatever drive you have plugged in is read only. Now to do this, you need a write blocker. Now you can either use a hardware write blocker, which is very expensive. I don't have one. although I don't mind getting gifts one. But for now, I'm using a software write blocker. A software write blocker still works. So we're going to be typing in the command to ensure that we have this flash drive in read-only mode. I already have mine switched on, but for the sake of this video, I'm going to be showing you guys to it. We're going to be typing in the command log dev set read to read only slash dev slash sdb. Then we click enter. Now you've right blocked your device, but you want to verify. It's very important to verify. Now, how do you verify that this device has been made to be a read only device? You do so by typing in the command log dev. Now, it gave us a value of 1. If it gives you a value of 1, it means it's read only. It has been write blocked successfully. If it gives you a value of 0, that means it still has read and write permission. So you have to run the command again. Probably there's something wrong somewhere. So now that we have a flash drive in read only mode, the next thing will be to carry on with the forensic acquisition. When you are creating a forensic image, you want to have a directory that your image is going to be outputted to. Now, in my desktop, I want the output of the forensic image to appear on my desktop, a folder called case 002. As you can see, I've already created that folder, mkdir case 002. That's the command. I'm within my desktop right now, so the next thing is to run the command. Uh, there's a little error here. This is an O, not a 0. So let's look at it. The command is dc3dd. There are various options written here. There's if, which means input file, and the name of the input file is slash dev slash sdb. That's why we're going to go and check the disks that were connected to our machine. Then the output file is our desktop in a folder called case 002. Now this is the name 2 gigabyte flash dot image is the name of the image file. And remember I said that dc3dd has a hashing feature, and we're going to be using it. So for forensic purposes, we use the more used the more prominent hashing algorithms that are used are SHA-512 and SHA-256, so whichever one you want to use. And then here is the log. So when the process is complete, we can choose to have logs, within the folder. And yeah, the name of our log is 2 gigabyte flash.log. So now that everything is complete, we're going to click enter. As you can see, it's started. So acquiring the image of the flash. This may take a bit, so let's chill. Right. So as we can see, the forensic acquisition of the drive is done. These are the number of sectors: 3,891,200 sectors. C is the same sectors that were outputted. Zero bad clusters replaced, and yeah, so there are no bad clusters in drive. But this is the most important part because this helps you to be able to verify the authenticity of your image. So this is the hashing of the image that was created. Now, to be able to access it, that's these are image, these are 2 gigabytes, these are log. So in order to be able to access the log, yeah, so this is the output of a log. It shows the name, it shows the name and the version of dc3dd that. Now all these information are very, very important because they hold weight when they are being presented for litigation purposes in court. So it's very, very important to know, to have the documentation of application that was used, the version that was used. Also, in case there are any errors, the date and time it was done. It also shows us the hash. Now, if we want to confirm, we can use the to verify if the hash is the same. We're going to hash the image again and see if it gives us the same value. SHA512 sum 2 gigabytes plus takes a bit of time. Proceed soon. So here it is. Here is the value. As you can see, it's the same. Now, one more thing. I'm going to leave you guys to run it by yourself. In a forensic investigation, we never use the same image file. We use the copies and we keep the original in a secure location, and we use as many copies as possible in order to prevent corruption. So just like how we made a forensic acquisition of this drive, you know, that output file is our original forensic acquisition. We can make copies of it. So in order to make copies of it, what you're going to do is to create another output file, right? You create another output file. You create another output file. You copy the path of this and you paste it here. You're going to paste it. Then you are going to change the name. So originally the name of our output file is 2 gigabyte flash.img. You can decide to create, you can decide to name that backup image as 2 gigabyte flash backup.img. If you want to create another backup, it's still the same process. So you create 3 output files within the same folder or in a different, you can do it differently. But you create that and you have backups. So store the original the original image in a secure location, and when you need to use it, you just create another backup in case you lose the backups you already have. So this is done in order to avoid corruption or modification that will cause the evidence not to be admissible in court. So that's it for this video. Thank you. If you've not subscribed, please subscribe, like this video, share it, and